Hello class, today I will continue the chapter 9. There's a chemical in industry. Okay, lesson 9.1, they're talking about the alloy. Let's see what is the alloy. Okay, first one, we're going to see the definition for the alloy. Alloy is a mixing two or more metal, or you say non-metal. Example is a steel, pewter, bronze, brass, and also dura. So this one is an example for the alloy. Alloying means the process. Alloying is a process. They want to mix two or more different metal. So together after, or you say mixing the metal with the carbon. So this one is a process for the alloy. That means inside the alloy, there's not just one of the atom. They are mixtures. Okay, alloying. Why we need to do the alloying? Okay, first one, they can more harder and stronger. So that means you add another atom, you find it, the metal now become more stronger. Okay, next one, they're more resistant for the corrosion. Okay, corrosion, if you can resistant, that means they will be last longer. Okay, after that, they're better for appearance. So that means maybe the surface, they look more interest. So this one is a reason why we do the alloying. Okay, now we're going to see the pure metal. Okay, pure metal, first one, there's a soft and not strong. So that's why we need to do the alloying. Okay, number two, because the size of the atom is the same. If the size of the atom for the pure metal is the same, so that means if I exert any forces, so that means they're easy to slide down. Easy to slide down means the molecule is the same part. The atom, every side is the same, so they're easy to move it. When they're easy to move it, that means you find it easy to destroy. So C, the layer of the atom that slide over one another, that's easily when the force just apply. So that's why we say pure metal is not strong, and also there's a soft. So example, pure metal, we got iron, we got copper, after that we got the aluminium. This all is a pure metal. Okay, now we're going to see alloy. Okay, alloy, the characteristic, they're just opposite with the metal. Okay, let's see first one, they say harder, stronger. Then after that, mixing with the different size of the atom. Okay, different size, that means you're not easy to slide down. Okay, C, made with the difficult to slide over with another. So can see the structure. We got big size, we got small size. When you mix together with the other element, so you find this one is more stronger. They're easy to destroy. So from here, we got some diagram. We got steel, we got bronze, we got brass. This all we call it as a alloy. Okay, let me see one by one. Okay, first one, the alloy we introduced as a steel. Okay, steel, the main metal should be the iron, 99%. Then the foreign, that means you go to add, we add the carbon. Carbon just add for 1%. Okay, so the properties, hard and strong. Okay, where we use the steel, we use as a bridge. You build the bridge, the material for the building. Okay, the frame of the vehicle, and also the railway track. Okay, railway track, the railway station, that means the train will pass through, is it? They're using more stronger, so they're replaced by the steel. Okay, the second alloy is a stainless steel. Okay, remember the stainless steel? That means they do not rust one. Okay, the main metal, there's a iron. Okay, after that, they join together with the forage. There's a chromium nickel. Chromium nickel, they add together with the iron. Okay, properties, resistant to corrosion, or you say rust. That means they can prevent rusting. Okay, where we use it normally is a kitchen tools. Okay, normally you want to eat the thing you want to prepare the food. They're created by stainless steel. So the kitchen tools such as a knife, fork, and also the spoon, or you say the pot. Okay, this all we using at the kitchen. So we want to cook something, so we want to prevent the rusting. Okay, let's see the third one. Third one is a pewter. Pewter, the main metal, there's a tin. Tin that stands for 96%. Okay, after that, they add about the foreign. We got antimony, 1%, copper, 3%. So when these two metals, they add together, they become alloy. So properties, shiny. The surface becomes shiny. corrosion resistant. So that means they can prevent the rusting also. Okay, we use as a container, the photo frame, and also the decorate item. Okay, now we go to the fourth one. There's a bronze. Okay, bronze, we're going to see the main metal. There's a copper. Okay, this one normally they as a medal lah. The third prize, the bronze they create for the medal. Okay, the forage they got tin 12%. Okay, what is the properties? First one is hard and shiny, corrosion resistant. After that, there's an attractive color. Okay, bronze got attractive color. So where we use it, we use as a coin. Okay, the money, the coin. Okay, after that as a medal and also the bell. Okay, the color just like a little bit gold, but not gold lah. There's a bronze. Okay, then we go to the next one. There's a brass. Okay, brass. There's a main metal. There's a copper. Okay, there's a 75% is a copper. Zinc just stand 25%. Okay, properties again strong, shiny surface. Okay, marble, gold in color. So normally where we use it as a keychain or locker, musical instrument like cymbals and also the trumpets. Okay, these all the color just like the gold, but not exactly gold lah. They're just shiny color surface. Okay, and the last one should be the duralumin. Okay, duralumin 95% stand for aluminium, copper for 3%, magnesium for 1%, manganese for 1%. So important is aluminium and copper lah. Properties light and strong, corrosion resistant. Okay, where we use it, the body of the aeroplane. Okay, body aeroplane, we're using the duralumin to build, or you can say about the shape, body of the shape. And the last one, the racing bike. Okay, this all they must have the strong surface to withstand the corrosion. Okay, so this one is the last one for the alloy. Okay, so after I introduce all the alloy, okay, they got one of the PKS. You need to complete it. So you just copy what I show you here. Okay, so the first one, this one experiment, the title should be comparison the hardness of the alloy and also the pure metal. So the first one is aim what you want to study. Okay, we need to study is the hardness of the alloy. That's higher than the pure metal. So we study the hardness of alloy than the pure metal. Okay, number two, what's the problem statement? The problem statement is they ask you, is it the alloy harder than pure metal? So this one is a question. So later we need to prove, is it yes or no? Now we see the hypothesis. Okay, the hypothesis, that means the earlier conclusion. We say alloy is harder than pure metal. So later we do the experiment, we need to prove, is it hypothesis accepted or not? Okay, now variable, what we control? We control is the type of the metal block. Okay, we're using the different type. Okay, maybe we change about the alloy. Okay, or you change about the pure metal. You're going to see what's the result. Okay, responding variable is a diameter of the tan. Okay, later you find it the box they will deform. When they deform, we want to measure the tan, kedalaman, inside got how many. If you more than means what, you're not strong. If you less, that means you're stronger. Okay, constant variable, diameter of the steel ball, height of the weight, mass of the weight. These all can be constant variable. These all things you can find from your textbook. Okay, before I see the textbook, your page number. Okay, chapter 9. You need to see the page number is 186. This one is experiment 9.1. One of the PKS you need to do. Okay, let's see the material what we use. Okay, we use a copper block, bronze. After that, cellophane tape and also the thread. So that means we need to compare the copper block and also the bronze block. Okay, copper is a metal, pure metal. Bronze is an alloy. Okay, apparatus, we're using steel ball, meter rule, 1 kg of the weight, retort stand with the clamp. Okay, now we see the diagram. Okay, the diagram arrangement like this. You got retort stand. Then you put the meter rule at the side. Okay, hang with the thread by using the weight. Okay, got one of weight. After that, this one is a copper block. We start with the copper block. Okay, this one is the steel ball. You put the cellophane tape, make the steel ball there on the surface of the copper block. Later, the thread, you need to cut it. Let the weight to hit the ball. Okay, after you hit the ball, you find the copper block to produce the dent, is it? So later we need to measure what is the cm, how many depth of the dent. Okay, let's see the procedure. First one, apparatus is set up. So you must write apparatus is prepared as a figure above. So you must draw the figure better. Okay, number 2, you constant the weight. So you mention the weight is how many? 1 kg weight is hang. Okay, how many? 50 cm. Make sure you constant the height also. 50 cm above the copper block. Okay, above the copper block. Okay, now the weight is released. Okay, you release, and there's a fall onto the steel ball attached to the copper block. Okay, when I hit the steel ball, after that you find number 4, the experiment you repeat. Okay, repeat twice. That means for the copper block, we do twice because later we need to find the mean value. Experiment repeated twice on the different surface, obtain an average diameter of the dent on the copper block. Okay, so now you're going to see the, after do the copper block, you're going to see the try another one, that's a bronze. Okay, number 6, you must repeat. Step 4 and 5 is repeated by replacing the copper block with the bronze block. So that means the procedure you just repeat, but now we go and see using the bronze block. Okay, now you see the result. So result you just copy here because we never do inside the school. So this one is the answer. Okay, first one we find it using the copper block. The dent is 2.9. Okay, when I do the second time, 2.9 also. Okay, so when I do the third time, okay, from the procedure we never mention third time. So if you never mention the third time, you don't need to copy the third time. If you want to copy the third time, so in your procedure you must say we repeated 3 times. Repeated 2 times. You do the first time, then you repeat 2 more. Okay, after that we find the average. Okay, bronze also same. 2.2, 2.1, 2.1. The last one I get 2.1. So from the result you find it, which one the dent is more deeper? Should be copper. Copper more deeper, what's the meaning? Copper is a soft metal. Bronze is harder, is it? So from here, we need to write about the, we go through discussion first. The last one is the conclusion. Discussion, you just copy here because your books don't have the discussion. Okay, discussion, we need to say the bronze block is harder than copper block. Okay, number 2, this one is a number 2. Number 2 is a drawing. Okay, I want you to draw the arrangement atom of the copper and also the bronze. So the copper must draw all the atoms same size and join together. Okay, bronze, you need to draw the atom also same size, but you add some of the different atom in. Either the atom you add is a bigger size or smaller size also can. So that means inside you must draw 2 types of the atom with the different size. So this one we call bronze block atom. Okay, and the last one, we need to answer why the bronze becomes stronger. This is because mixing of the different size of the atom of bronze make it more difficult to slide over one another. Okay, so this one just I want to answer the question number 1. Okay, bronze block is more harder than copper. So number 2, you just drawing. Number 3, you say this is because, okay, the mixing with the different size. So that's why they become more stronger. So the last one is a conclusion. Alloy is harder than pure metal. Then you need to add the sentence. The hypothesis is accepted. Okay, so I repeat again the first part. There should be the aim. Okay, number 2, there should be the problem statement. Okay, number 3, that is a hypothesis. Okay, number 4, variable. Variable separate by 3. manipulate, responding, and constant. Okay, after that, number 5 is material. Then number 6 is together with the apparatus. Okay, after that, we need to draw. Draw first. Draw and label. After draw, copy all the procedure. Okay, procedure, I repeat again. If you got do the third, that means you repeated twice, that means you need to mention. Because from here, I just mentioned repeat one time only. So you repeat one more, then you repeat twice. Okay? So if you repeat one only, that means later your table just got 2 readings only. If you repeat 2 times, that means your label, same like just I show you, there's a 3 column. Okay, after procedure, you need to draw the table for the result. Okay, the result must have the block, copper block, and bronze. After that, you must say about the dent, 1, 2, 3, because you do 3 times. Then you find the average. Okay, after that, follow here, discussion. Discussion, you got 3. 1, from here. Second one, drawing. Third one, reason. And last, conclusion. Okay, so this one is your PKS. You must do it. Then after that, you need to pass up when I go to school. Okay, then we go to the next part. Okay, next part is another experiment. So that means you do the PKS just now. I don't know how many, maybe 5, PKS 5. So this one should be PKS 6. Okay, let's see the PKS 6. Experiment, they want to comparing the corrosion of alloy and pure metal. This one also your textbook. Okay, just now I show you there's a 1x6, is it? This one is a 1x7. Okay, they want to compare again alloy and pure metal, but this one is a corrosion. Okay, let's see the aim. Again, to study the resistance to corrosion of alloy as compared to the pure metal. Problem statement. Problem statement is, what's the problem statement? From here, your problem statement is alloy more resistant to corrosion than pure metal? So the question we ask is it the alloy is stronger or not? So your hypothesis is yes, alloy is more resistant to corrosion than the pure metal. So we need to prove is it hypothesis correct or not. Okay, let's see the manipulated variable. Manipulated variable, we're using the different type of the nail. Okay, one sure is an alloy, another one sure is a pure metal. Okay, responding, that means later we're going to see got corrosion or not. So the corrosion here, they represent by the presence of the brown layer on the nail, mean the rusting. Okay, if present means now that one the nail is not stronger. Okay, so we need to check about brown layer, the brown layer. Okay, constant variable, the size of the nail. So make sure 2 sides should be the same. Okay, solution. Both also must put inside same solution. So from here, we just put inside the water. Okay, duration of the experiment also must be constant. Maybe you put 1 week. Okay, 2 also must be 1 week. You cannot say this one 1 day, another one 1 week. That means you get the result should be different. So from here, this all must be constant variable. Okay, let's see the material. What we use it for this one PKS. Okay, we use the iron nail and also the steel nail. So we want to differentiate. One is an alloy, one is a pure metal. So after that, we use a solution should be the water. Water level must be the same. So apparatus, we're using the test tube. Okay, after that, the test tube rack, because they want to put the test tube. So from here, let's see the procedure. First one, the test tube we label first. First one, they label by P. Okay, P is an iron nail. Another one is a Q. Q is a steel nail. Okay, P and Q are filled with the 10 ml water. So the water volume must be the same. Okay, 3, the iron nail is put into the test tube P. Another one is steel nail they put into the test tube Q. Okay, so this one, we need to keep it. We need to keep it for a week. So that means just how many seconds we cannot see the result. So we need to leave for the 1 week. Okay, duration for the both test tube must be the same. Okay, after a week, we do the observation and also record the data. So you record the data, just follow my table here. Okay, so from here, you just write 2 columns. Okay, first one is the type of the nail. You just label iron nail and steel nail. Okay, number 2, result. The pressure of the brown layer on the nail. So we find it, the iron sure got brown layer. They got brown solid produced. Then the steel is no changes. Okay, so from here what we prove? We prove the steel is more resistant corrosion compared to the pure metal. So this one is a result. Then we go to the okay, let's see the discussion. First one, we say iron nail will rust after a week. So number 2, you need to draw the arrangement for the atom. Okay, iron nail, the atom is the same size and join together. Steel nail also join together, but you need to add some of the atom different size. Okay, number 3, we give the result why the iron will rust, why the steel is unchanged. So the answer is because the mixing of the different size of the atom of the steel, they make the steel is more harder and also more resistant to corrosion. So the conclusion here, alloy is more resistant to corrosion than the pure metal. So you must say that hypothesis is accepted. So this one is another PKS you need to do. So for this topic, make sure you do the 2 PKS. Okay, do inside the foolscap paper. Okay, separate 2 PKS. When I come back to school, then you pass up to me. Okay, then we go to use of the alloy in daily life. Okay, let's see the use of the alloy in daily life. Okay, first one we're using is a superconductor alloy. Okay, what's a superconductor? Okay, a superconductor is one of the electrical conductor with zero electrical resistance. Zero electrical resistance means they don't have any penghalang. That means you can move easily to flow the electricity in a certain temperature. So that means they don't have anything to block you. The electricity can flow through. Okay, flow through anyway, and also you no need provide the current and also the voltage. They're easy to flow through, but this one got the rules. They got certain temperature. Not every alloy also can. Okay, number 2, they say allow the high current to flow through them without producing the heat. Okay, they can produce a high current, but you no need provide the heat some more. They also has a result same like the normal conductor. So that means we can save the energy. Okay, number 3, they also show the diamagnetic properties which are repelled by the magnet. Let's see the first diagram. The first diagram, can you see they repel with the magnet? So that means they never attract together with the magnet. So example, you can see the train. Okay, this one we call maglev train. So from here, they're using the superconductor and the track is a magnet. So they never attract the magnet. They will lift up. When they just lift up, then they move. Okay, we got 2 situations. One is attract the track, then you move. Another one is lift up and move. Which one become faster? Sure must be lift up, is it? Lift up, that means you don't have any friction together with the track. Then you will move faster. So this one we normally apply for the bullet train. So that's why they can move faster. In how many seconds they can move how many kilometers. So they're using the superconductor. So let's see the uses of the superconductor. First one should be the transportation. Okay, the levitation train. Okay, maglev, there's a bullet train. Okay, another one we using the alloy superconductor also in the MRI scan, or you can say about the CT scan. Okay, now we're going to see another alloy. There's a steel. Where we use it, the steel, they use as a constructing the building. Why we use as a building? Because there's a hardness and also resistant to corrosion. Okay, another is a duralumin. Duralumin we use as build the body of the plane. Why we use this one alloy? Because there's a light and also there's a strong. So the last one should be your exercise lah. So you need to complete the page 189, the exercise 9.1. Copy the 3 questions and answer it. So the next lesson, sure I will show about the answer. So hopefully what you understand about this topic. Okay, so thank you for your watching. This one is what I want to send to you for chapter 9.1.